Well, hello friends. Welcome back to the program. Today we are going to work on the terminal in Serenity. So we have a very long-standing bug where if you get some kind of garbage characters on the terminal, it crashes. And it happens in the UTF-8 decoder. So we hit this assertion, where is it? Wait, that's not the one that I'm looking for. We hit this thing right here, UTF-8 view. First byte makes sense. So I've hit this like 100 times in videos, and it's because we assume that all of the data that comes into the terminal is valid UTF-8. And it's not, right, in this case. But we do have some support for emojis that was added a long time ago. So let's actually create like a little emoji test file for this. What's a good one? How about the ladybug? Right? So maybe we can just copy this character here and put that into an emoji txt file. So let's just put 5 of those ladybugs here. And then, we should be able to display this ladybug emoji in the terminal, right? But you can kind of see a problem here, which is that the emojis are multi-byte characters, but we're not aware of that because the terminal program thinks of each character cell here in this buffer as 1 byte. And in Unicode, you can have multi-byte characters, right? So I think the ladybug emoji is probably 4 bytes. Let me verify that, or I should do it here. Emoji is 5 of them, so it's 4 bytes each and then a new line, right? So we would want these to show as one single character, and also we would want to handle garbage coming in, like when you cat at random. So these two problems have kind of a solution that fixes both of them, and it's to make the terminal more Unicode aware, right? So today we're gonna turn it from a basic byte buffer into a Unicode CodePoint buffer instead. So instead of each cell being 1 byte, it's going to be an arbitrary CodePoint. So we'll use like a 32-bit value for the character cells. And then, of course, that's kind of wasteful if you have like a huge amount of terminal history. So we'll probably want to do some optimizations for that, so that in the very common case where you have only ASCII, right, then we don't want to waste a whole bunch of memory just in case some character is wider than 1 byte, in case there actually aren't any. But anyway, let's just get started. So the first thing we're going to do is go in the terminal widget, and then I'll show you what it looks like when data comes in here. So actually, it doesn't come into the terminal widget, it comes into the terminal. And the terminal is a class that lives in the VT library, so the virtual terminal library. And a terminal is essentially a buffer of lines. And 1 line is like a horizontal line of text, or really characters. So when data comes into the terminal object, we end up in, what's it called, on char? Yeah, on char. And this is where we have the state machine that parses the escape sequences and stuff like that. And basically, since it's a terminal, we're only going to get 1 byte at a time sometimes, and it's probably better to just fit a UTF decoder into the state machine than it would be to sort of rely on input coming in nice chunks that are all valid UTF-8 or whatever. So I think we're just going to extend the state machine to parse UTF-8. and turn that into Unicode. Or I guess UTF-32, or whatever you call it. So in order to accommodate that, we should fix up the line data structure so that it can have U32 instead of U8. So currently each character cell is, so this is one line, right? So one line is an array of characters and then an array of attributes. And attributes are like the color, the bold, the underline, stuff like that. So I think here we'll just change the character array to 32. Oops, 32. And then maybe we will rename it to CodePoints. Can we do that? CodePoints. Just because it has kind of nice ring to it. And it's, I feel like if you say CodePoint, then it's sort of distinct from character, which I'm just removing this thing here because I don't think this is going to be useful to us. Because this is no longer compatible with string view, because string view is a view onto 8-bit data. And we want to work with this. So let's see. Okay. And then let's look here. We just look for the warnings. So when we change the length of a line, we can't allocate U32 anymore. We have to allocate, we can't allocate U8. We have to allocate U32. And then we probably can't mem copy like this, but we can instead just do and then we should rename that to new code points. Oops, there we go. Do we have any more mem set? Yeah, that's not going to work either. So, oops. This is just if you do like a clear, then we just want to put a space character in every character cell. Previously, we could do that with memset since one character cell was 1 byte, but now we have to use we have to go 32 bits at a time. So memset's not going to cut it. All right, so maybe this is, let's see if we can, maybe we can make it work with 32-bit characters as a separate initial patch. That would be kind of nice. Terminal insists on thinking characters and bytes are the same thing. Right, so this is the terminal widget painting logic, and it's pretty weird right now because it was set up to support emoji, but we very specifically targeted supporting that instead of making like a sort of generic Unicode buffer. So what we currently do is that we iterate through all of the rows, and then we try to print the whole row in one go as a UTF-8 string, and if the content on the row happens to be valid UTF-8, then it all works out. But if it's invalid, that's when we hit that assertion. So that's why this is falling apart. But I think basically what we're going to want to do here is just get rid of this UTF-8 view stuff and make this a simple, like first you iterate each line, and then you iterate each column in the line, and then you just like print out each or paint each character or code point as you go. So let's get rid of UTF-8 view entirely. And let's see. So here we're like iterating UTF-8 view, getting code points like that. So what if instead we just did I, and then I is line length plus I, and code point is line code points I. And then we just ignore this stuff. And let's see. So now we have a loop. It will just go one code point at a time. And then what is this? This is doing the backgrounds. So previously, because one character could span multiple cells, we had to do the background for one character possibly spanning multiple cells. So I think that's what this is. Basically, so it's going from this character's starting column to the end of the current character. So this is really weird, and we can just get rid of this because now one character equals one column, right? So I guess this is just a bool that we have up here, so we're getting rid of that. And then this doesn't need to be a loop anymore either. So wait, hold on. This was looping to down here. All right. And then column. Oh, I guess we should say that this is the column, actually. Column. There we go. And maybe we can simplify these by just auto, clickety click, click, click. Wow, look at all that code disappearing. Isn't that nice? And then the stuff here seems like we already have something called character rect. So maybe we can just skip creating those. Num columns. Wait, what's num columns? Oh, that's how many columns this character takes up. Well, let's just not do that. Because now a character is only one column. So I think this is pretty good. Now this is not gonna, it's not gonna support emoji anymore. Oh right, characters changed name. Line characters, where did we not change it? 346. Why didn't you change? Column. Non-constant expression cannot be narrowed. Well, I'm sorry. I will narrow you to an int manually. And then terminals. We have to update these guys. Right. So it's not going to support emojis now because it was supporting emojis because we were, oh, well, look at that, because we were just passing the whole line to the GUI paint code as a UTF-8 string, and then the paint code would figure out what each code point was. But now, it still sort of works. What happens if we cat emoji? Yeah, so no emojis. And then these question marks are a bit weird. Wonder where they come from. Let's see, did we mess something up here in the line code? The mem set right here. We can't do that. New length. I feel like that was the problem. Yeah. Okay, so here we are. Can we cat that random? We actually can. Oh, there we died. Because, right, so this is Windows Server is disconnecting the terminal because the terminal attempts to set the window title to something that's not valid UTF-8. So it actually kind of works now. It's just that when we parse one of those things to send to the Windows Server, then we mess up. So SetWindowTitle, this thing here does not care about the validity of what it sends out. But I think this is a good start. So let's commit this, and then we can build on top of this, so we don't like mix everything up. So say let vt switch vt line to being backed by 32-bit Unicode code points. This will allow us to have much better Unicode and emoji support. And also it kind of sort of already fixed the whole crash on invalid thing issue, although not entirely. So let's see. It does incur a memory usage regression, which we'll have to optimize. We'll have to optimize to cover. Yeah. So now we want to actually parse UTF-8 though, because now we don't support showing those emojis anymore, and we want to see those ladybugs in the terminal, right? So let's see, we'll go in terminal on char. So the way that this is called, by the way, is that the terminal widget, whenever he gets input on the pseudo terminal, then he just loops over the input and passes it to mterminal on char, one character at a time. And because this is just data that we got from a read syscall, we don't know if it ends at a nice boundary or right in the middle of a UTF-8 character or something. We just can't know that. So we have to handle it character by character. So maybe, I don't like this name so much, on char, so let's call it like, we'll call it something else, on input maybe. And I also don't like escape state if we're going to put a decoder here, so let's rename that to just parser state. Yeah. The vt tweak input parsing related names. Okay, and then we'll need some new states here. So I'm gonna need to bring up a cheat sheet because I don't remember exactly how UTF-8 is encoded. I know that it's between 1 and 4 bytes per character, and the top bits of the first byte tell you how to interpret the following ones. Yeah, so this is a good table here. So if it's a 1-byte character, then the top bit is 0, and then these are like data bits. So these are the characters. So the whole ASCII character set fits in UTF-8 as 1 byte. And the way you know that it's an ASCII character is that the top bit is not set. So, and then if it's a 2-byte character, then the top 3 bits look like this, and then the next 5 bits are part of your CodePoint, and then you have the following byte has the top 2 bits looking like this, and then the bottom 6 bits are part of the CodePoint. So you basically have to look at the first byte, so and then determines how many more bytes we need to look for, and then you get 6 bits from each additional byte towards your CodePoint, which means that you can have a total of 21 CodePoint bits in the 4-byte case. So it's not a full range 32-bit CodePoint. It's actually less than that, but this will be okay. So I guess we'll go into some state. We can call it UTF. Should we call it UTF-8? Needs 3 bytes, maybe. So that's the state we would go in if we hit one of these guys. So if we see this pattern, then we go into needs 3 bytes, and then we would sort of go into something like this, right? Those would be our 3 states. And then we need to accumulate the code point somewhere. So code point, something like that. What's that last character? Oh, wait. It's probably a code, should be a U32 now. Let's see if we can fix that. Let's fix that before fixing anything else. So let's change you to a code point. So we don't forget about it. Yeah, that's good. VT. Change terminal and last chart from U8 to U32. We can write it this way. Okay. Now we want those states again that I added here. So let's put those back with some super crafty text editing here. Current code point, M code point maybe, something like that. Current, let's call it current code point. Or code point being parsed maybe. Parser code point. I don't know, something to separate it. Because the last code point, it's like this totally other thing, unrelated to the parser. The last code point is the rightmost code point on a line. Because terminals have this weird behavior that when you get to the very last character on the line, wait, is this what this is about? Now I have to double check. M last code point. No, maybe I'm messing this up. I am messing it up. It's not the last character on the line, it's just the last thing that we actually outputted. And, okay, so forget what I was starting to say. This is just, we remember the last character that we output to the terminal, and then there is an escape sequence that repeats the last character. So that's what it's used for. Okay. And then this thing here should definitely also take a U32. So let's fix that also since we're here. U32, put character at. Okay. Yes, yes, no. Maybe we can add it to the previous one. Maybe these things should really go into the... They should really be folded into the commit I did before, into the backed by 32-bit code points. Okay, let's let me rebase here just to not make a mess of history. So this one gets squashed into that one. Yeah. And then we get reset head tilde 1, and we are back where we want it to be. Right. Sorry about that. So let's look at the parsing now. So now we have these 3 new parser states, and we can go into the parser. So it's like an incremental parser, right? And then the normal or baseline state is called normal. And this is, if we are in the normal state, that means that we're not currently processing like an escape sequence. So here is where we normally are. And we're going to have to extend the state. So we'll look at the top bit of the first of a byte that we get. So for a normal state, we get a byte that doesn't have the top bit set. That means that it's an ASCII character, right? So we can just break. And the thing here is that if you break, it will go down here and do actually output the thing to the terminal. So this takes care of new lines, stuff like that. And then down here, it actually prints the character to screen. So basically, this function is divided into, this is the escape sequence parser, soon to be escape sequence plus UTF-8 parser. And then here is control, like cursor movement processing, so backspace, tab, new line, stuff like that. And then down here is regular text. So this is where we just print the character and advance the cursor. So we want to fall down there if it's just ASCII. You'll notice here that all the escape sequence parsing stuff will return rather than break. So we'll like return and wait for a new character. Okay. So if it's ASCII, we break. If it is, now we want to look for this pattern here. So what is that? It's the top 3 bits, which means that it's every bit except this guy. So that would be CH and hex E0. If those are equal to top 2 bits only set, so C0, then we want to go into the state UTF-8 needs 1 byte, right? Because we already have 1 byte and we need 1 more. And the parser code point is going to be these 5 bits. So the bottom 5 bits of the thing that we are processing. And then we can return. And then when we come back, we'll be in this state. And let's see how we handle, maybe we can do like this. And then, because all of these 3 states here, they require a byte that starts with 10. So we can say like if character and C0 is not C0, then fail UTF-8 parse, something like that. Otherwise, advance UTF-8 parse. And then we'll make those helpers in a moment. We'll just need to start it out. So for the this case right here, we need the top 4 bits to be the top 3 bits set. So and fo should be EO. And then we need 2 bytes following. And the parser code point is the bottom 4 bits. So and OF. Then we have 1 more state. So that would be this guy right here. So the top 5 bits, meaning fate, ch and fate has to be fo. And then we need 3 bytes, and the parser code point is the bottom 3 bits alone. All right, and if none of these conditions are met, that means that what we have is an invalid sequence, right? It's not valid UTF-8. But instead of choking at this point, like the more assuming UTF-8 view code would do, now we have total control of the parsing, right? So we can just say fail UTF-8 parse and return. Okay, so let's decide what these things actually do. I was thinking we could just put them up here. Fail UTF-8 parse. And what would it do? It would, I guess it would like emit a code point. It's like emit code point. Wait, what's emit string? Client emit. Oh, no, emit is not what I want. It goes in the other direction. Never mind that one. Call it on code point then. So we'll just like send out a question mark. Maybe we can try a funner one. We can try what's a fun character? Is there such a thing as a fun character? Let's do %. And then we want to return the state to normal. Actually, we can do that here. So this will be what we do when we fail. And advance UTF-8 parse will just be parser state is parser state +1. Wait, what did we call those? Oh, this escape state. Oh, I should have changed that name earlier. Parser state. Well, whatever. That's okay. So it will be parser state from that. Maybe we should even say that. Or no, that's okay. And here, what we want to do is we want to accumulate bits into the code point. So it's only the first one that has a variable number of bits, and all of the following ones, it's always 6 bits. So we just take whatever we have accumulated in the parser code point so far, shift it left by 6 bits, and then we OR in whatever we just got. So ch and the bottom 6 bits, so x3f, right? Oh, and we don't see ch here, so we can do that. Okay. And I guess actually if m parser state is UTF-8 need 1 byte, that means that this is the end and it's time to on code point. So we'll do on code point, parser code point, and then we will return to normal. Otherwise we will advance, right? And then we just need to come up with this on code point thing. So terminal on code point, something like that. And I think we can just take all of this stuff right here and just say on code point cha. So here, if you're here, that means that you have an ASCII character, right? So we just pass it through to on code point. Otherwise, we're calling it from the decoder stuff with a full code point. Yes, let's put a private function for that. Okay. Maybe we can tidy this up a tiny amount here, so we'll just do this. That's nice. Will this work? I feel like I probably got one of those bit masks wrong. Yeah, we messed something up here. So I guess we should probably print out something. Where did I want to go here? So wait, for ASCII it was just working, right? So we could see what we were doing at least. Yeah, for ASCII it works, but for this, totally messes up somehow. So what are we messing up? So these are four byte emojis. Let's verify that actually. Hexdump emoji. Right, so faux9f99e. That appears to be one ladybug, right? Because we have the same pattern repeating here. Which means that this has all the top 4 bits set, which is exactly this pattern right here. And what state would we go into, I wonder? So wait a minute. I guess we can dump out what's going on. So 2 byte UTF-8. Okay, so we're accurately hitting the 4 byte UTF-8 path every time. That's good. And here, we're starting it out with the bottom 3 bits, which are going to be zeros, right? Yeah. And then we should enter the needs 3 byte state. So we'll be here. And we are checking if the top 2 bits are not the top 2 bits. So if the top 2 bits are not set, then we fail. Otherwise we advance. So we're definitely hitting fail, but why are we hitting fail though? Let's see. I guess we can do this. Fail in state. Let's see which state we're failing. Fail in state 8. Oh, did we ever advance, actually? I feel like we're probably not even advancing once. We never advance. Look at that. Okay. So this thing is not working out. Wait a minute. There's a break here. That's not good. That means that the first time through, we will fall down and hit this path here, which we don't want to. So that's definitely something we need to fix, but I feel like we're still failing sooner than that. Why are we failing so soon, I wonder? Oh, wait. What was that? Oh, here's a fail UTF-8. That's okay, though. Okay, so at least I got rid of the weird spaces. So we're failing in state 8. And which one is that? It's 9, 8. Okay, all right. Fail in state. We can be cool and log what is the character or the byte at that point. We're solving it with printf debugging. So what is it? 159, and we think that that's not good. And what is that in hexamundo? It's 9f, right? Hexdump is 9f. So it's this character right here, and we are failing it. Wait. I'm checking if the top 2 bits are set, but the top 2 bits should be only the toppest one. Okay, so that's the problem. So this should be 8, 0, right? Only the top bit should be set. Okay, well, that was a silly problem. Then we don't need this stuff or that stuff, and we can... Still getting used to the Ninja commands, but it's working out okay so far. Boom! Look at that. We have our emojis, which are arbitrary Unicode code points, and they all take up one cell each. Very nice. And if we cat that random, it works. It's going to work until it tries to set the window title to something stupid. So I think we can deal with that separately. But this is pretty cool though. So let's commit this. libvt parse incoming UTF-8 add incremental UTF-8 parsing to the terminal input handler. Instead of relying on GUI code to handle UTF-8, we now process and parse the incoming data into 32-bit code points ourselves. This means that you can now show emojis in the terminal, and they will only take up one character cell each. Very important. Okay, so that's pretty good. And oh shit, we should have gotten rid of these debug captures that I did here. Still builds? Nope. Because I needed that capture. It was not a debug capture. Now it still builds. Okay. So let's deal with that window title issue as well. So basically, we get an xterm request to send a window title to the terminal client, and the terminal client. So because the terminal is implemented in sort of a presentation agnostic way, libvt provides a terminal object which you can then embed in whatever way you like, and we also have the terminal widget, which then has a terminal object internally, and then terminal widget implements the painting and everything, and like event handling. So the way we handle set window title escape sequences is that we inform the client, hey, there was a request to set the window title. This is because I have this ambition to share code between the kernel and the graphical terminal, because the kernel has like a basic terminal for the text console, and it would be really cool if we could have the text console and the GUI terminal share the terminal emulator implementation, right? So that's where this is, but that's the kernel still uses its own implementation. It's just I would like to get to a place where they can share this. So that's what this is about. So I think one thing we could do here is to just accept that he's going to send us trash, and then we would filter here. So we would like do like if UTF-8 view title, like if we can't validate that, we'll validate at this point. Then just ignore. Maybe we can whine a little bit. Terminal widget. Tempted to set window title to invalid UTF-8 string, something like that. And then we'll actually need to put this back just for the validation. But I think that's okay. So if we do this, we should be able to cat the random forever, and we should just see garbage here, and we should see occasional whining about the window title at some point, I would expect. So all of these no such file or directory, this is because of the way we do Unicode symbol lookup. So let's see if we can stop this. Yes, it actually worked. So the way that the emoji actually shows up on screen is actually kind of curious. So I'll show you. When we encounter any Unicode CodePoint, basically, or I don't remember if it's range limited. Let me look that up. Emoji, draw emoji, draw a glyph or emoji. Right, so if the code point is less than 256, then we just draw it from a font. Otherwise, we will attempt to open it as an emoji, but really an emoji is just any code point above 255. And what we do is we just look in res emoji for a file name with this pattern. So u plus and then a code point number. So if we go to res, let me do this in a convoluted way just to play with the system. In res emoji, we can find these are all the emojis that we have at the moment. And really they're more like Unicode characters, right? But I think the idea that we had was we would put emojis here because the emojis would be the same for all fonts, and then fonts would be more concerned with just text, right? So I don't know if we would want to add more characters here just to do text. I don't think that makes sense. This is more like for code points that are shared between all fonts. Although we might want to come up with something for bigger versions, because these are super tiny. This is supposed to be the laughing, crying emoji. I drew these on a train ride last year, and I took requests from people, so these were the ones that Sergey wanted, I think. This one was important. And then there was a glass of milk and a unicorn. This one was for Dan, and then Dan added this one. Good times. And then these ones here, I think Hussein made recently, so that this up here is actually a Unicode code point now. It used to be implemented differently. Anyway, so this is pretty cool, right? Now we can actually show emojis here. And what happens if we put some emoji that we can't, like if we have something that we can't show, I guess we just get this whiny output. So this is whining because it can't find a PNG in res emoji, right? Now, to support this in text editor, this would be a different project, which I'm not going to do now, but we should do that too. Text editor suffers from the same problem, that it's makes assumptions about one character cell being 1 byte, and it shouldn't be like that. Anyway, let's see, libvt. Don't try to set the window title to invalid. UTF-8 text. Yeah. And I wanted to put some emoji that we couldn't see. What's a good emoji that people like these days? Let's see which ones are popular. Can we go to Emojipedia? I think they have like most popular. Yeah. The thumb up. Well, we don't have that. We should probably have a thumb up emoji, right? Click, click, click. Wow. Now that's aesthetic, isn't it? So if we do that, we just get question marks. But see, that's pretty good though. So now if we wanted to add this emoji, what we would do is we would just go in base, res emoji, and the name of it needs to be, it should be on the bottom here, U plus 1F for 4D. Right, so that's what we want to call it, and I think we'll just copy something here to the correct name, and then we can GIMP this guy, and then we will just make a thumb up emoji right quick here. See, so this was the ladybug. Now let's make a thumb up instead. Do we have anything to draw based on? I feel like we have a thumb up in the, yeah, so this is a thumb up I drew for the system monitor. And it doesn't have that emoji tint quite, so maybe we can, wait, how do you do this? That's not the one I wanted. I always forget how this works. If I just wanted to yellowize it a little bit, maybe saturate the hell out of it. No, these are not good. Let's get the colors from here. So I'll take this obnoxious one and this other obnoxious one, and then we'll just start like that and do it like that. And take some other color here. I don't know about this one and that one. Oopsie doopsie. Okay. Oh shit, that's not what I wanted. I wanted to do, the outline should be dark, yeah. Doing the important stuff here now. And then let's grab a lighter shade from somewhere. There. That wasn't lighter, that was, yeah, well, it's still okay. But it is too big, so this one has to be 7 by 10. Now how much can we shave this down to? 13 by 16. So we need to be in this little space right here. Oh shite. Well, that's gonna be tough. So I guess we can just forget about using that big space, and we can just do something like this, right? For our memoji. Wait, that's better. And then we'll just put some, I don't know, some finger action here. And this doesn't look very super great, but I don't know. Like it's the thought that counts, I'm gonna say here. Can we do that? How does that look? Maybe it's not so bad. We should really come up with a way to have bigger emojis so you can have some space to draw, because it is a bit silly. Anyway, let's see how this works. Boom, look at that. We got our little thumbs ups, and we got our ladybugs. Ladybirds. So I'm gonna say that was good enough for me. So I'll add this guy. Say base, add a basic thumbs up sign emoji. 44D. Ching. Anyways, that's how you do that. So if anybody feels like drawing little 7 by 10 emojis, then be my guest. It's surprisingly difficult to communicate anything in such a small set of pixels, but it is fun. So anyway, I think this is going to be the end of today's video. So if you made it this far, then I thank you for watching and hanging out. And I hope that you saw something interesting. I'm really happy with with the progress here, because this crashy terminal bug has been plaguing us forever, and now I finally sat down to deal with it, so that's really good. Anyways, thanks for hanging out, and I'll see you next time.